All right, guys, so good afternoon. Today we are continuing on circle theorem. And just to recap some of the major theorems based on what you're looking at in this diagram. Now you notice that these are major ones that you will see pop up in questions. And just to say this, guy, with circle theorem questions, what they do, they will embed more than one theorem in one question. So what you'll find is that they can merge these theorems together and put them in just one question. So your ability to isolate them and see them individually is what is really important for you to be able to work them through. All right, guys, so when you're approaching a question, just bear in mind that you want to isolate each of the theorem that you're learning. That is the reason why it is important for you to be very familiar with them, because if you're not, then you're going to overlook some of them. All right. So this one says the inscribed angles subtended by the same arc are equal. Now, just another thing to know, these theorems are described differently with different texts. So even though you may see this theorem and they might be explained in a different text in a different way, the exact same thing. So inscribed angle subtend on the same arc. What it really means is that if you have an angle within the same segment at the circumference, all of these angles are equal. And the segment that we are referring to is the segment, that line that cuts the circle in two different parts. All right, so it's a straight chord that cuts the circle in two parts. And remember now, a segment is different from a sector in that a sector is based on slicing out a piece of the circle from the center, like just as how you slice out a cake. All right. Now, so when we're referring to this first theorem, we're really looking at the circle being cut into two segments. If you notice that the part of the circumference here that is highlighted in burgundy, and it goes from A to B, that arc is so we talk about segment and we talk about arc. But remember now, an arc is just a section of the circumference. So this highlighted burgundy area is a section of the entire circumference, and this is called the arc AB. Right? Now, this arc from A to B, if you draw a card from A to B, you will notice that, and I probably should do this with a different color. Let me see if I can change that color, guys. All right, and let me use black. All right, so that line that you draw from A to B actually cuts the circle in two parts. And the part that is above the line AB is one segment where you find all of these angles are subtended on the circumference in that part of the circle. Or in other words, these angles are subtended on the arc in that segment. Now, the arc in the lower segment would be the burgundy arc from A to B, but above the line AB would be the major arc, which is the arc that remains after you take off the arc AB. All right, so within that segment, all of these angles are formed at the arc of that segment, And so all of those angles will be the same because they are formed on the same arc in the same segment. So that's all this theorem is saying. Now, the second one that we have here where it says angle subtended by the diameter of a circle is 90 degrees. Now, if you imagine this as the same theorem that we were looking at above, but now the line or the chord that we are working with is not the chord of center of the circle, but now we have a chord that passes right through the center of the circle. So this chord that passed through the center of the circle would cut the circle in two halves and still two segments. All right, now the lower half would be, you notice that you have the arc AB highlighted by the burgundy color. Now in the other segment, you will also have an angle subtended in the other segment. But this second theorem is really a byproduct of the last one that we have down here, right? Even though they're saying angles within a semicircle is 90 degrees, it is still based on the one down below that says angle formed at the center from a point AB is twice the angle that forms at the circumference within that opposite sector. All right, so I'll explain that when I'm looking at this one in a little bit more detail. But the angle that forms at the center is 2x. The one that forms in the opposite sector is x. Now, if you remember that sector is a slice of a circle. So now this sector that forms with A and B is slicing it out from the middle. That sector is bounded by this arc, which is a minor arc AB. So this minor arc AB would slice out this sector. And so the angle that is formed at the tip of that sector at the center is 2x. Now the angle that is formed in the other sector, now this other sector would be the sector remaining after you take out the slice AB. So over here, over here, after you take out the slice AB, you would have that part remain. So this part is another sector, but you notice that the angle is formed at the circumference within that sector. So that's a major sector. So this angle is half the angle at the center. Now, if you look at this one up here, it's the same thing. The angle at the center here would be 180. And then now the angle up here would be 90. So it is pretty much the same rule that we are following as the one down here. All right, guys, is that clear to you? Ms. Green, do you understand what was being said so far? Ms. Cabrera?
Yes, sir.
Okay. All right, so these are some circle theorems. And these are the major ones that you should look out for. Now, what we want to look at next is the tangent theorem. So these are circle theorem, and we want to look at tangent theorem. These are some other aspects of the circle theorem that we just look at, but these are somewhat drawn to be a little bit more complicated, but this is really based on the third theorem that we're looking at here. So we say angle that forms within at the center within this smaller sector. So the angle that forms at the center of the circle within the smaller sector, the smaller slice, is twice the angle that forms on the circumference or at the arc of the larger sector. So this one here going to be twice half this one here. All right. Now this one, this theorem is basically the same thing as this. The angle that is formed now in this sector at the center is twice the angle that forms in the other sector, the remaining sector at the circumference. So it's two sectors. One angle forms at the center of one sector, and the other one forms at the circumference of the other. So the one that forms in the center is twice the one that forms at the circumference. All right. So these two are basically the same thing. They only are drawn with the sectors shape a little different, but it's the same principle. All right. So this part I was saying now, this is actually the same theorem that we were just looking at just now. So the angle that forms at the center, based on this sector sliced out with the pink radius, the angle that forms at this center would be twice the one that forms at the circumference within the other sector. So if you take out this sector, that's one sector. So the angle that forms at the center of that, the circle of that sector, the one that forms in the remaining sector after you take out that slice at the circumference, going to be half that one. Sorry guys, give me a second. All right, sorry about that, guys. So, so even though these diagrams are drawn to look complicated, you just need to isolate the theorem within it, right? This one here is drawn with a card down here, but it's the same principle. If you take out this sector, the angle that forms at the center going to be twice the angle that forms at the circumference within the other sector. All right, so those are the things to look for when you're dealing with circle theorem, right? Now, theorems connecting arc and chord. So these are some theorems that you can just make a note of. Equal chords make equal arcs. That means if you have the same chord in terms of the length, and you cut it at the circle at different parts, the arc that it forms. And just to clarify that, the arc, so this is a chord, and the chord generally goes from one point on the circumference to another. And if you have a chord from one point of the circumference to another, then the chord going to cut the circle into two segments. Is that clear? So we are saying that equal length chord, no matter where it cuts a circle, once the length would be the same, let's just go back to the theorem and say, so it is saying that equal chord makes equal arc. Now, it means that this arc formed down here, if you use the same chord and cut somewhere else on the circle, or in other words, if you draw a line from one point on the circumference with the same length chord, let's say for instance from here to here, what they are saying that this arc, the arc would be referred to that section of the circumference. And they are saying that this arc and this arc would have the same length because they are formed using the same length of chords. So this chord and this chord have the same length. That means the arc formed from them will be of the same length. That's all that is saying. Is that clear, guys? So equal chord makes equal arc. Equal arcs subtends equal angle at the circumference. And equal arc are subtended by equal angle at the circumference. So these are just some little things to note. All right. Now we're going to jump into now tangent theorem. All right. Now tangent theorem has to do with a line which we call a tangent. Once the line is touching the circle at a point, that point at which the line touches the circle is where we call the point of tangency. So when the line is tangent to the circle, it is really touching the circle at a point. So if the line is not touching the circle, then it would not be referred to as a tangent line. Is that clear, guys? Raise your hand if it is clear, guys. Okay. All right. So based on having a line and a circle and a point of tangency, that's why we have what we call a tangent theorem. Now, in most books, they don't really separate tangent theorem from circle theorem. Most books will have the tangent theorem as a part of the circle theorem. So even though we are saying tangent theorem, it might be very well thought of as circle theorem. All right. So definition of a tangent. A tangent is a line which just touches a circle at a point of tangency, or a point only, one point only. This point is called the point of tangency. All right, so let us look at some theorems involving the tangent. Now, a tangent to a circle is at right angle to the radius drawn from the point of tangency. Now, what that is saying. Now, this line outside the circle, touching the circle at this point, at the point of tangency, we are saying if you draw, the radius from that point of tangency, and you know that the radius would go right to the center of the circle. So if you draw a radius from the point of tangency to the center of the circle, that radius is going to be at right angle with the tangent line, right? So, and that's where you are seeing this. So that's a theorem that you must remember. Now you need to know these theorem, guys, because you will, without knowing the theorem, you won't be able to know how to determine angles. So the theorems are what we are using to, based on the theorem, we are using these theorems to determine angles. So you have to know the theorems. All right, guys. So that's the first tangent theorem we're looking at. So let us look at another one. All right, so here is another tangent theorem. Now, if from a point outside a circle, two tangents are drawn to the circle, then the two tangents are equal in length. All right, so what this is saying, from a point outside the circle, so they are referring to the point C. All right, so this point C outside the circle, right? If from a point outside a circle, two tangents are drawn, that means you're going to draw from this point a line which is tangent to the circle at A, because it must touch the circle at a point for it to be tangent. So this line from C to A or from A to C will be tangent to the circle at A. And if you draw another tangent line from C so that it is tangent to the circle at B, then what they are saying is that the two tangent lines are equal in length. That means the length of the line BC is also the same length of the line AC. Is that clear, guys? Raise your hand. Is it clear? All right, good. Now, so that is important. Now, one of the other things that you could do now, if you consider drawing a radius to the point A and drawing another radius to the point B, then what you would have constructed with that tangent line is two right angle triangles. And the two right angle triangles would be symmetric to each other, meaning that if you fold them over on each other, they will be sitting perfectly on each other if you fold them through the line from O to C. So this line O to C would be the line of symmetry. When you fold over A onto B, it will be a perfect right angle triangle folded onto itself. All right. Now, so just knowing this theorem can give you a sense of you having a right angle triangle. And so you'll know that the right angle would form at the point of tangency. So a right angle at A and a right angle at B. Now, with all of that, you would be able to determine what angle C is with that line drawn through the center. So if this angle is X, then clearly this angle over here going to also be X. And this would be based on the fact that they are similar triangles. The two right angles are exactly the same. So they are similar triangles, so they're going to have similar angles. So the angle right at the center here, this is Y, then this angle on this side is also Y, right? And we already know that these are right angles. So these are things to note. And so when you see a question with tangent from outside, you have to remember these. All right, guys? Moving along, next theorem. All right, so this one is saying now, the angle between a tangent and a chord drawn from a point of tangency is half the angle at the center of the circle. All right, so this theorem is referring to the tangent line, which is the line running along B to C. So that's a tangent line. And they're referring to a chord. And the chord would be from the point of tangency. And so the chord would start at B. It's a chord, so it's going to be falling somewhere else at the circumference. So this chord would fall on A, right? And so the theorem is saying that a chord that that starts from this line. So they are saying that the chord from B to A forms an angle with the tangent line, which is theta. And that chord, the angle that forms between that chord and the tangent line, will be half the angle at the center formed from the two radius from A and B. So the angle at the center here will be twice the angle formed with the tangent line and the chord. Is that clear, guys? So this theorem is saying.
Oh, I don't understand what you're saying.
All right, let me just show that once more. All right, so it is saying that this tangent line, right? This is the line, this tangent line. And this chord, right? So the chord comes from B, which is a point of where the tangent line forms the point of tangent. That's where the tangent line touches this circumference. So a line or a chord drawn from that point to A, right? And this chord will start from one point on the circumference and end at another point on the circumference. So the theorem is saying is that the angle formed with the chord and the tangent is half the angle formed at the center. So you can read this two ways. You can say that this angle is half of what is at the center here. So if let's say that this was X, then this angle here would be half of X. You follow? Or if you want to say if this is theta, then this angle will be twice theta. So you can read it two ways. Is that clear, Miss Green?
Yes, sir.
Right. Now note that the angle formed at the center is formed by the two radii, right? Remember that this line from the point of tangent to the center is one radius, and the other from the center back to A is another radius. And these two radii form the angle at the center. So you should pay attention to how this diagram is formed, because when you're really looking for the theorem, you're trying to see the exact thing that you have here.